So Víctor Blanco is going to talk to us about infrared thermography and beyond Industry 4.0. So now we are giving you the role of presenter, so you can share with us your presentation.
Okay.
Yeah,
I can see my screen.
Yeah.
Okay, so thanks, Alex, and hello to the over 100 participants that we have at this webinar. I hope all of you are in good health. And well, in line with the excellent introductions to machine learning and to machine vision made by Jose Angel, Elena, and Santi, I will explain what we do in a company, in BCB, regarding infrared thermography. So, well, BCB, we are an official distributor and an integrator of FLIR, the main manufacturer of infrared cameras in the world. So we take care of the business in Spain and Mexico. It's a company that has been established in 1996, and we have a branch in Mexico. And we specialize in providing thermographic engineering solutions, both to industry and to research. And as you can imagine, in the current times, also to medical applications such as fever screening. These are the technologies we use. We are experts in machine vision, in data acquisition. We integrate different instruments. We work on test automation, communications, integrate on our sensors. And regarding machine vision, we work mainly with infrared cameras, FLIR, and also with combined vision with visible cameras, 3D, hyperspectral, depending on the application. So the machine vision and the artificial intelligence algorithms are applied to process monitoring, control, automatic detection of defects of colors, shapes, dimension and control, and of course to non-contact measurement of temperature. Regarding artificial intelligence and big data, these are technologies we are used to work with. We work on self-learning machine vision based on historical data. We can identify complex patterns within the volumes of data for a precise prediction of defects and for the automatic self-adjustment of parameters. And we can extract information which is very valuable both for process optimization and for product optimization. Further to being a dealer of the FLIR cameras and experts in thermography, we develop our own software solutions. We use natural language tools both for industry and research. And our platform is the BCB Monitor, and here we integrate miscellaneous multiple combination of thermographic sensors, image management software, and other additional elements, so we can offer a complete monitoring solution, which is usually customized according to the specific needs of the customer's processes. Also, we have a variant, the BCB Research, for research and development, with some additional capabilities than the one dedicated to industry and to medical applications. And we work in three main sectors. One is automation and industry, and the second one is research and development. We are quite active in European national calls. And the third one is thermosolar power plants, where we have over 10-year experience. Well, this is just a brief sample of some of the latest projects we have been working in, but when we share this presentation, so I will not go into much detail with this. And regarding thermography and machine vision within Industry 4.0, thermography is quite a transversal tool for many industrial sectors. We can see here some examples for aluminum casting, rotating furnaces, welding, production of paper, rubber, die casting, or hot stamping. Also, electronics. We can perform a thermographic analysis of components, printed circuit boards, LEDs. We can monitor critical equipment or electrical substations. And we can also work on process monitoring in many industries, for example, in the steel, foundry, or automotive industries. And these are some examples of applications of infrared thermography in the food industry. So we can do, as I mentioned before, continuous monitoring of critical elements, machinery and other elements. And also we can control the consistent quality of the product, of the process, and also work on predictive maintenance of the production machinery. Regarding the steel sector, we can, for example, predict the wear of the refractory bricks or the inspection of in a continuous casting, or the wear of the electrodes in an arc furnace, among other applications. In the automotive industry, we have also a number of applications that also incorporate machine learning and artificial intelligence, both for quality, testing, production, maintenance, and research and development. And here we have, for example, some examples of testing, leak tests, for example, or engine and engine component tests. And also regarding predictive maintenance, there are some applications of electrical maintenance and mechanical supervisions. These are some of the advantages of infrared thermography regarding predictive maintenance. We can have a real-time visualization of the images, define as many regions of interest as we need. We can obtain graphs of the last 24 hours of measurements. We can generate temperature allowance in real time, display patterns, record videos, images, and radiometric information. And we can use this stored information. We can retrieve them later for a further study and to learn patterns. Or we can, for example, record an image of a process. If you have a thermal camera, a thermographic camera, which is a variant of the more advanced thermal camera, we can say. Well, we have in reality thousands of thermocouples, vertical thermocouples in this case. So if we want to retrieve we have a radiometric image, some weeks, months, years in time, so we can access to recorded images and move the regions of interest, the areas that we want to study, and maybe we can detect, we can suspect that there is a failure in some case, so we can make a historical graph of the thermal evolution in that area, so we can see what happened, or if there are any areas of the process or of the product that can be affected, for example, by a quality issue. These are some examples in the energy sector for solar thermal power plants. So we are the company that has calibrated probably more heliostats in the world. Our latest projects have been in South Africa and in China. If you have a field of heliostats pointing to a specific area in the tower, so you can imagine what will happen. We can imagine what will happen if the energy is not pointing to the right direction, that we are just using energy. But if this energy is pointed to the tower, but to the structure of the tower, we can destroy the tower. So it is very important to have this calibrated, and also we use our specific software and algorithms to perform this very special application. These are some examples in CCP solar thermal power plants, detection of salts, automatic inspection of tubes, tanks, some applications in medical imaging, diabetes, skin burns, brown fat, psychology, or cancer. And we also have, as I mentioned our specific BCB temp scan software for the monitoring of elevated body temperature. You will see that there is a lot of noise in the media regarding this application, but nobody is clear about the specific characteristics that a camera or a system for this very special application must meet. There are specific regulations, ISO and IEC, that many suppliers that are on the media don't meet. So we have developed together with the clear cameras approved by the FDA, the American FDA, so the best in the market. So we also apply our BCB temp scan software. And just so everybody can learn a little bit. You have seen what we are doing in BCB, and now we'll finish with just some recommendations, 5 steps for building, deploying deep learning neural networks. You know that deep learning is a small part of artificial intelligence, machine learning, or representation learning. So it's we can say more advanced than other components in the artificial intelligence landscape. And some advantages for deep learning neural networks, which are applied to thermography. So we can replace millions of lines of code with by a simple neural network. And we have to train the neural network, of course, with images, and we need very little coding. There are a lot of tutorials that are easy to find, and there are many opportunities for your machine vision systems to do things that were previously unimaginable some years ago. For example, we can use deep learning for the recognition of unexpected anomalies that are impossible to achieve with traditional coding. Also, with deep learning, we can.
Victor, sorry for interacting.
Yes?
We have one or two.
Yeah, okay, it's enough. It's just for a slide. We can allow complex decisions to be performed with minimal hardware, very little processing power. And well, we'll go to the next one, just that will go a bit faster. So the 5 steps for building and deploying a deep learning neural network applied to thermography is first to identify the appropriate deep learning function, classification, detection, localization, segmentations, and detection of anomalies. Then we have to select the framework, the tool set in common language that we would use. Here are some examples: TensorFlow, Caffe2, OpenVINO, PyTorch. Then we have to prepare the training data for the neural network. After that, we have to train and validate the neural network to ensure accuracy. And the 5th step is to deploy the neural network and run inference on new data. You can see here some applications of thermography, for example, for ADAS system. In high traffic environments, you can detect pedestrians, animals, cars, urban furniture, or in electronics, you can predict if a component in a PCB is going to fail or not from the temperature it has. This is another example with, well, in the food industry, we can detect anomalies, strange bodies. You can control the right cooking temperature, the right packaging, and there are also some potential shortcomings of the deep learning. So not only is sunlight, there is also some darkness, but very little. For example, deep learning is a black box. It's difficult to figure out how the neural network arrives at its decision. And this is critical, for example, for the American FDA, the Food and Drug Administration, to approve to certify a product. Another issue is that it's very hard to optimize your neural network in a predictable manner. And also, there is the human errors, which account for all the accuracy of the neural network. And also, it is very difficult to debug a problem. And also, well, deep learning is good, but not for all applications. Some applications are better suited for logic-based solutions. Well, so just as a summary, even with some of the shortcomings that I have highlighted, the potential benefits from deep learning outweigh the negatives. Just to name a few: rapid development, ability to solve complex problems, ease of use and deployment, etc. And furthermore, there are constant improvements being made in the field of deep learning that are overcoming these shortcomings. So I remain at your disposal for any questions, and these are our contact data, so please feel free to write me anytime regarding thermography. And thanks to all. That's all by now.
Great, Victor. Thank you very much for your very interesting talk. You can leave your questions here. I have just a simple one. So from BCB, do you, because as far as I understand, for instance, what you do is that you take the FLIR cameras, right? Do you integrate them with your own software, or the software from these cameras or any other cameras that you distribute also have already machine learning implemented in the software?
Well, we have our own software solution, which is more advanced than the solutions that the camera manufacturers, FLIR is the main one we work with. So our software has additional functions, more advanced. So we specialize. That's why we are BCB Informática and Control. So we have been working the BCB monitoring and its variants for many years. And the possibilities of the software are, of course, much more ample, advanced than the ones offered by the traditional software that these cameras implement.
Okay.
And also we make specific solutions for any special applications, and we have the version for research as well.
Okay, that was my next question. So if someone has
Thank you, Alex.
interest, they can contact you, and you can together develop a specific application for their needs. Right?
Okay.
Okay. Okay. So thank you very much, Victor, for your talk. If you can leave your email here as well.